to go to the total quality tool first. What is total quality tool? Uh, Basically, we have basic 7 tool, which includes Pareto, check sheet, cause and effect diagram. I think we have done last week, and then I have explained to you what was your mistake on the cause and effect diagram. Histogram, I think you are familiar with this because this is from your undergraduate, I guess. Scatter diagram, when you have data for the XY, so you can plot the scatter diagram. So I just give you some overview about uh, how to read the scatter diagram and so on, how to interpret data and so on. And then I will give you a brief on the control chart, today. Uh, then tomorrow I will go detail on the control chart. Then we will on the certification as well. But after finishing this, I will link with what we have learned this morning. What we can say is the 7 quality tool. Please accept my apology for my bad handwriting. Then I will further continue with the new 7 tool. I think you are also familiar with this. For example, affinity diagram, decision tree diagram, critical path method, and so on. What I can say, the Pareto, check sheet, and etc. This is kind of basic quality tool. So I think you go beyond than this in your organization where you are quite familiar with affinity diagram, tree diagram, interrelationship diagram, and so on. So first, I would like to introduce what is Pareto. It's about 20-80 rules. 80-20 rules. So in quality, although this looks small, 20%, but it might contribute to the majority. So in quality, we cannot just simply ignore what is small. What is small, and sometimes we think this is unnecessary. If you remember what I've shown you before, iceberg, this is what we see. This is hidden. Maybe it is hidden, the hidden one is 80% because the stone is floating. You just see this 20% and you think that this 20% is very small. You just ignore this. But without we realize this 20% contributes to the disaster, tsunami in the future. For example, I'm taking example on your car. So because everybody are driving car. On the wheel, we have a bearing. Maybe you notice there is a sound coming from your wheel. Very slow sound. It's not really strong. It doesn't really strong. You just ignore that. Then you still travel as usual. You go to work, back home. You go back to your hometown, etc. You assume that small problem. That sound from the wheel is a small problem. That's 20%. But what happens if the bearing is broken and your wheel stuck? The worst case scenario at the high speed, at the highway, 160 km/h. So it causes accident. That affect that 80%. So that's maybe among example. Or maybe we think that now most of the cars using timing chain. We talk about car using timing belt. Or 60,000 kilometer, 80,000 kilometer, we have to change the timing belt. No problem. Why do we extend up to 120,000 kilometer? That's small. So you extend a little bit, you maybe the cost for changing the timing belt for Proton, Saga, for example, Mira, cost you around few hundred, 200 ringgit. Why don't we extend it a bit so we can extend to further 40,000 kilometer? We can save around 40 ringgit. Without you realize your timing belt broken. When timing belt broken, it's like stroke. People got stroke. So all the components inside the engine is uncontrollable. The purpose of timing belt is to control the timing of your valve. So when the timing belt broken, the valve is uncontrollable. So the valve will fall down and then it will hit with the piston head. So it costs a lot for the overhaul. Instead of saving 40 ringgit, you might spend 3,000 ringgit for the new engine, second-hand engine. Or maybe if you want to do overhaul instead of changing the engine, cost you also a few thousand. That's 80% when timing belt broken. So moral of the story is that according to Wilfredo Pareto, we cannot ignore the small defect or small problem or small symptom in the organization. This is what we call a Pareto chart. The y-axis, normally y-axis, we call it, this is dependent variable. This is dependent variable. And of course, this on the x-axis is the independent. So always put the dependent variable on the y-axis. Maybe this is your yield. Always put the dependent variable on the y-axis. Okay, so our yield, what we want, that's the effect. Dependent variable always the effect if we want to refer to the fishbone diagram. So your yield is a reward cost. This is being reported by the Gamba, maybe. And these are among independent variable that causes reward costs. And this is the cumulative of the occurrence. So when we want to plot a Pareto, first, we have to rearrange the data. We have to rearrange our independent variable to the dependent variable. So we shift the independent variable that has higher value for the yield to the left. And then followed by the second one, third one, fourth, and so forth. And this one, why we put it here? Because it is others. It's not, it does kind of miscellaneous. And then we have to calculate the occurrence. So of course, for this failure part, we know the frequency. By knowing the frequency for each, we total up the frequency, we know how many percent it occurs for that particular independent variable. So we know the percentage. Later I will show you the example. I'm sorry, I know that most of you are familiar with this, but in order to accommodate those who are not from the engineering background maybe. So I have to be fair to repeat this. So maybe this is kind of a refreshment for you, fresh up. Okay, again, this one. This is also Pareto plot. But what is interesting here is, if you remember to 5 why, 1 how method, we can use this Pareto for the 5 why and 1 how as well. So what pull our interest here, we have top 5 defects that contributes to the reward cost. But what we want to see here is that this is 80%, 80%, these are 80%, but these are 20%. It looks minimal. But costs incurred by the failure part is huge, followed by miswire. So you want to investigate the 5 why for this problem. So why part failure? Part failure maybe because of this. Because of this. These are the independent variable. These are the independent variable. Then we investigate the percentage of failure for each. And open contact contributes about nearly 70%. So why open contact? We have to find out the reason why open contact. Maybe it is because of miswire, wrong part, short, open, solder, and etc. Then next, why? Because of hand wrap. Solder, for this case, this example, they ask for why misfire because of this. Why misfire? Because of this. So then, cascade down, hand wrap is the majority, close to 80%. So they want, this is very minimal, but they want to know really why hand wrap? Because of this. Operator tool, but the operator contributes a lot, near to 70%. Which operator? So finally, we know this is the source of the problem. So near to 60% total hand wrap defect because of operator number 33. And this hand wrap contributes to the miswire, contributes to the open contact, and contributes to the part failure. So what is the how? So we have to think about it. Check what is the problem with this operator number 33. Maybe send training. Maybe check whether his physical is not suitable for that job, maybe. I want to share with you about Prodwa. At the Prodwa Dojo, before they interview the new operator, the operator was tested about their capability. There are many tests. I saw the test kit. One of the tests is, you know, the guy should stand here, and then there is a hole here. The guy should throw a ping pong ball to this small hole. Focus test. And then smell test, and lot of then the guy given 5 golf ball, and the guy has to rotate the golf ball clockwise, counterclockwise on the right hand and left hand. Why? Because they want to evaluate the capability, the physical capability, the psychomotor capability of the people. Eye concentration to throw the ball into the hole, and so forth. There are a lot of tests before the operator being interviewed. Also the smell test, because they want to get the sensitivity of their nose towards smell of the chemical, especially those who are working in a painting shop. Their nose should be sensitive to the types of chemical. And those on the Pareto, later I will give you exercise. And this is a cause and effect diagram. I think you are familiar with cause and effect diagram. I think I have shown you last week what is cause and effect diagram. So this is your dependent variable, and these are your independent. So what caused to this effect? What caused that to that effect? So that's the purpose of this fishbowl diagram. From this data, remember what Dr. Deming always said, many companies, they are full of data, but they are poor with information. We have data here. Causes for solder defect. Can we get any information from this? Definitely we can't. So if we can classify into man, material, machines, environment, for example. So it can give us information that we put on this cause and effect diagram. Why do we classify like this? Machine, man or operator, materials, environment, method, and the measurement that affect the solder defect. From this data, we classify into this, and then we put under each categories, machine, operator, and so on. So this can give us better information. This is what we want, what we say information. From data, doesn't tell us anything, but when we plot into information, it gives us information. What caused to the solder defect? And we can also use affinity diagram instead. So we have the big issue is a solder defect. What are the sub-issues to the solder defect? So from that sub-issues, we can get the opinion to solve that sub-issues. And with the interrelationship diagram, we can get the relationship of the sub-issues and the ideas, solution. So that's how affinity diagram related to the uh, interrelationship diagram. Okay, let's look into this example. So how to draw the Pareto? I have to go very basic. Maybe we have A, B, C, D, E, F here. Then we have to count the frequency. F if the frequency. So A, how many A we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22. B, we count again for B, B1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. Then we do the same until D, E, and F. We count the total of everything. And for each, we can get the percentage. 22 divided by total is total 12 multiplied by 5. 60. 22 divided by 60 times 100. 15, 60, 100. So we got the answer. Example, $36.67. $25. So from here, basically we can plot. A is the independent variable. For example, this is, I take 10, 20, for example. A, we have 22 here. Then B, 15 here. So we count the highest frequency we put on the left. Because I didn't count for C, D, E, and F. Sorry. Wait. Internet interruption, I guess. Okay. So we have to count the highest frequency on the left and then followed by the second highest on the left also. The left one should be the highest one. So then from here we can do the cumulative. So maybe for A, 36%. So I put 20, 40, and so on. For A, 36%, maybe it's around here. 36, and B maybe 25. So we have to count the cumulative. 36.67 plus 25, so 67, 11, 6. So maybe this is 60, so 61 is around here. So that's how we do the cumulative. I hope I'm giving you the idea how to draw the cumulative for this Pareto and then Pareto plot for the each frequency, drawing the histogram for each frequency. Okay, that's on the developing the Pareto. Then we have check sheet. What is check sheet? because we have data, but we want to show our data in the visual form. That's the purpose of chat sheet. One friend of mine says that when he worked in Paradua, he told me how he verify his chat sheet. Normally, after he finish develop the chat sheet, he will bring the chat sheet to the most idiot operator to verify the chat sheet. So if that guy can understand the chat sheet, it means that other people will also understand the chat sheet. Because the principle of designing chat sheet is understood by the brain. When you see, you know already the information. You don't have to think. That's how we design the chat sheet. This is very important statement. The fuel that powers total quality tool is data. Again, data is very important. Particularly nowadays, during data analytics era. So it's really important. But how you're going to capture your data to make it as data analytics? If you still use the conventional way, you collect data, write down in a piece of paper, and then you file it. Then finally the file you kept in the storeroom. So it's a waste because you cannot analyze the data. So make sure every single data you collect, it should be ICT based, and you should be able to store the data, and then the data should be analyzed. Many companies literally they are drowning with their own data. Or maybe you have good ICT system to collect your data, but without knowing how to analyze the data, convert it into information, you might be drowning with your own data. So why don't you analyze the data, convert into information? Company that is drowning with data, they are data rich, information poor. PT to that company. So if you look at to this chart, maybe you have the data logger to capture this data for 1 week. But looking to this, without analyze this, without maybe analysis is maybe something that you have to think, you have to use statistic. But if we were to build a chat sheet, it's simple. You don't have to think about it, actually. You just draw it. Or maybe you program it in your computer, in your system, so that by clicking it to any icon, it will show you the information. So by looking to this, it doesn't tell you anything. This doesn't tell you anything. No information at all. But if you rearrange your data from here to here, it tells you something. It tells you something. This is what we call chat sheet. This is chat sheet. You have shaft length. Initially it was like this. So you rearrange the shaft line like this. And then you count the frequency of occurrence. 11 of July, 12 July, 13 July, and so forth. You have the date here, you have the length, so you can count. Of course, before you have like this, you should find out what is the value for length. Or maybe you can set the class instead of putting line like this, maybe you can put the class. So you count the frequency from the class. If you like to do the class, then you can plot. So you know that this is the majority. And then maybe you have the limit. This is your limit. So from this check sheet, it shows your tendency is on the upper limit rather than lower limit. And it shows that it's kind of skewed to the upper limit. Before this, you cannot see anything. With this simple check sheet, you have the information. This is for 1 week maybe. And you have the specification. Anything outside this, you reject. Or we go back to the miswire issues just now. So you know that the operator was the culprit. Now we want to find out the how aspect, the how. You have operator 8, 10, maybe they have their names, but we just use a number. And then this is the bench where they are working. And this is the date and morning and evening. So we just count the defect. These are the defect, the mistake that they did. So you count how many defect due to a hand wrap, how many defect due to solder point to point, harness, others, and so on. Then you count the defect, it shows operator number 33 contributes to the mistake, did a lot of mistake, followed by number 28. So then you know already the detail, because the management, before you want to report anything, maybe from the Pareto that we have did before, you know already operator number 33 and 20 as a problem. But you cannot just simply report like that without go into detail. How was the trend for their mistake? Because you want to analyze whether this operator, physical or their psychomotor is not capable to do the job, or what, or maybe they have skill problem or whatever. So you can, from this analysis, it help you for your decision. Or maybe you want to just, this is also a check sheet, you want to see only how many reject and how many defect. In the company that we visited last couple of weeks, last 2 weeks, told us the time and how many accept, how many reject for that particular time. So that is a check sheet as well, because this gives us information. But this is data. Why data? Because it doesn't tell us anything. But when we convert this into check sheet, it tells us something. And more importantly, read by the brain. Another one is the histogram. Like we have done just now, we count the frequency. By counting the frequency, we can plot the histogram. For example, like this. But if you want to draw Pareto, we just shift this one to the left. But if we want to plot in the normal distribution, we plot this way. The highest should be in the middle. Highest frequency is in the middle and followed to the second highest on the left and right. That's how we do histogram plot, because we want, finally we want to draw the, we want to see the normality. But if you want to draw the Pareto, we shift this one to the left. For example, this one, we have in total 100 samples, and rate bit is the dot on each sample. So they count how many dot for each sample. So sample with 0 dot is 0. Sample with 1 dot, 1 sample. Sample with 2 dot, 3 sample. With 4 dot, 90 sample. 10 dot, 0 sample. So total dot, total sample is 100. This is total sample. Is N. Sample, we label it as N, small n. So we write down this information to this way. How many rate bit? How many sample? Total sample is 100. Then we want to know the population, the total rate bits, total dots for all the sample. That's what we want to know. So why don't we, if you want to know that, we should have another column here. Then we multiply how many rate bit multiplied by sample. We know the how many total, how many dots for this subgroup. This is what we call a subgroup. Then after we know the multiply, we total is, this is the total of population. The symbol is capital N. So when we multiply that, so we know we have 5, 10 dots for all the samples. So if we want to know the mean of the dot, we just divide by N. This is the X bar, the average or the mean. Then we are interested with the deviation, because deviation later on we related with the variation. The purpose is we want to reduce the variation. The purpose of improvement, the quality improvement, is we want to reduce the variation. So before we can count the variation, before we can calculate the variation, we want to know the deviation. How it deviates from the mean. Deviation means how much it deviates from the mean. So whatever we have, number of rate bit, we minus mean. So minus 5.1. 1 minus 5.1 minus 4.1. 3 minus 5.1 minus 2.1. 8 minus 5.1, 2.9. So we minus this with the mean. If we can plot this y value, basically, the x, we can plot this, the x value. So the value, okay, the x value, maybe like this. So we have this is the mean or 5.1, whatever. Just I want to show you the idea. This is what we call deviation. This is the deviation. How much it deviates from the mean. That's why we minus. We minus this one to the mean value. So we get the distance. What if we have one dot that is far away from the mean? What do we call this? This is what we call outlier. That is outlier. So we go back to this one. I hope you get the understanding about the deviation. Means how much it is misaligned from the mean. And then after that, after we have the deviation, we square the deviation. We square the deviation like this. And then we multiply the square deviation with the number of sample. How many samples we have? We multiply this, we got this. So this, we call it sum of deviation squared. Sum of deviation squared. Deviation squared is this. This is deviation squared. Number of sample multiplied by deviation squared. We got the answer here. Then we sum of all these deviation squared give us this one. And this will tell us the standard deviation. Like this. This is the formula. Standard deviation squared is variance. So it's equal to sum of your deviation squared. Sum of your deviation squared. Sum of your deviation squared divide by n minus 1. N minus 1 is sample. Why minus 1? Because it tells you the degree of freedom. What is the definition of degree of freedom? Let's say you have 5 circles here. The number of circles n equal to 4. What is degree of freedom? Is how many freedom you have. That's what we call it, degree of freedom. You stand based on this one, your freedom, you can move to this one, and this one. So you have 3 degrees of freedom for this for sample. So that's how we define degree of freedom. From yourself, you have 1, so you hold 1, the rest, how many freedom you have? We have 100 here, 100 here, so the freedom we have is 99. So divide by 99. So we have the standard deviation, sigma is standard deviation, 1.49. That is 1 sigma. 1 sigma, 1.49. So what is the 3 sigma? We multiply by 3. So that's how to calculate the standard deviation. Use Excel. I know you are familiar with this already. How to use Excel to calculate the standard deviation? Actually, there are 2 types of standard deviation in the Excel. First is the sample standard deviation. Sample standard deviation. Another one is the population standard deviation. If you use wrong command, it will give you wrong answer. Particularly if your number of sample is small. But for the bigger sample size, you will find that regardless you use the sample standard deviation for sample formula, or if you use standard deviation for population formula, it will give you more or less the same answer for the big number of sample. But if the sample number is small, if you use the wrong formula, the answer will be different. Okay, I show you this how. Standard deviation. I hope you can see my screen. If you cannot see my screen, now I'm showing Excel for hard Excel. If you don't see this, please let me know. Okay, in this HAP, it shows that standard deviation function. Standard deviation is measure how widely value are dispersed from the average or from the mean. Important, this function has been replaced with one or more new function. So previously, they used only one STDEV function. But today, if you still want to use this STDEV, no problem, you can use it. But now they have improved with this standard deviation for population, P for population. This is a command, STDEV P. And another one is standard deviation for sample. If you see here, standard deviation for population is divided by N only, but standard deviation for sample divided by N minus 1. That is the difference in terms of the formula. It is still same D squared, sum of D squared, but on the deviation is different. For standard deviation for population divided by N only, but standard deviation for sample N minus 1. So let's try use this formula for sample. SDDEVA, then we highlight the value. So highlight the value, close. This is the standard deviation for these values. This is based on N minus 1. How about if we divide with N only? Divide with N, standard deviation for population. Sorry. Dot P. Then highlight here. The answer is different. Can you see? The answer is different. Because why? Because our samples is small. But if we have 1,000 data, so regardless you use STDEVA or STDEV.P, you will get more or less the same answer. Okay, how about if we use the old command with .A or with .P? Then we highlight here. It's the same. So STDEVA is the same with STDEV command in the Excel. As I mentioned before, square of the standard deviation will give you the variance. So this is standard deviation. So what is the variance? The square. Sum had 2. Close. This is the variance. So in Excel, they also have the command for variance. Also, they have VE out. This is the old command. And this is the variant for population. We can use this as well for population. So let's say I use this variant to check, to verify this. Equal VER, open up. The answer is the same. How about VERP? VERP dot P, yeah? VER dot P. Okay, this is for population, and for population, sorry, and VER dot P different. So standard deviation is squared, a variance is squared of standard deviation. So let's use that formula for n. Sum is 1. The answer is same. So this is the variance for population. This is variance for sample. So now I have shown you in Excel or in mathematics, in statistics, there are two types of formulation for variance and standard deviation. First one is for sample, which the deviation we minus 1. Total number of sample minus 1, because we are dealing with the degree of freedom. But when we have population, when we deal with population, we just divide by number of population, N, capital N. That's the difference. So we have a formula for standard deviation and variance for sample and for population. Remember, when we have lot of sample, when the size of sample is huge, we might find, regardless it is a sample or population, the answer is the same. The next quality tool is the scatter diagram. Maybe this is the simplest 7 basic quality tool, like this. When you have your dependent variable, which is on the y-axis, and independent variable on the x-axis, you can plot this. Maybe you can use Excel to plot it. But what we are interested more is on the correlation. When you have data, you plot the scatter plot. So this one shows the strong correlation. Why strong correlation? Because the data distribution is close to the mean. When it's close to the mean, it shows strong correlation. But if the data distribution far from the mean, doesn't have tendency to the mean, like this, it shows weak correlation. Whether it is positive correlation or negative correlation doesn't matter, but this is what we want to see. The density of the population, or the intensity of the population, that is correlation. So whether it is strong correlation or weak correlation. In quality improvement, what we expect is to reduce the correlation, to make the correlation stronger. When the correlation stronger means low variation. And this one, C, has no correlation at all. For this one, for example, it shows the correlation, good correlation. So if we use Excel, we can get the regression for this. We can get the regression line like this, curve like this. So from the regression line, we know the minimum level for reject at which convergence speed, for example. Temperature and time, this is the correlation. And surface to rotation revolution per minute. Revolution per minute is the independent. This is our yield, our dependent. This one can be plotted at this. Plant A, B, C, and D. Lost time for plant A is 5. 5 is something around here. So we want to see how the effect of time lost per day because of injury and overtime hours are related. So overtime is cost. That's why we call it dependent. We want to see lost time per day because of injury and how much this injury costs in terms of the overtime hours. So, because why it is effect, why it is dependent, because this is the interest of the company. They want to know the cost of this. So we put this as at the y-axis. So injury time versus y-axis, then we know that loss of time due to injuries is will increase the overtime hours. And see, here we can see the variation. And tomorrow I will teach you on the statistical process control. But today, under the 7 quality tool, I will show you the run chart only. What is run chart? Run chart is a run. We want to see the trend. That's the purpose of run chart, because we want to see the trend only. So when we see the trend, like this is the trend. We only notice that the percentage of defect is reduced by days. But it doesn't tell us anything until we have the mean, until we have the limits. That is under SPC, Statistical Process Control. And what we want to know also in the Statistical Process Control, SPC, is the special cause or common cause. We want to know the variation result of special cause and common cause. That's I will teach you tomorrow on the SPC. This is the SPC. By having the upper limit, lower limit, and the average, we know the special cause. And who promotes this? Dr. Deming and Dr. Joran. In 1950s, they promote this because they want to show information, graphic representation of the process. That's the information that we want to share. Okay. Then flow chart. So I will explain to you about flow chart, and I believe all of you are familiar with this already. Flow chart is a graphic representation of the process, particularly during audit. As I mentioned before, the auditor wants to see your process, your procedure. We engineer, we are not interested with text, with paragraph. But when you show us graphic, you show us graph, then that will make us wake up from sleep. So this is among standard symbol for flowchart. In fact, we have more nowadays. This is the very basic ones. If you want to start the process, maybe you can use oval or rounded and rectangle. But if we have square rectangle like this is processes. If you want to make decision, you use diamond like this. This is when you prepare something. Parallelogram, when you have input and output. If you need to refer to manual documentation or whatever, this is the symbol for documentation. And this, maybe you want to connect to somewhere, you use connector circle like this. And this is the connection line. This is simple flowchart. I think you have done this in your company. We begin with here, accept defective customer unit. The process is troubleshooting. So if we find the problem, locate. If we find the problem, we replace the defective. If not, we have to troubleshoot again until we find the problem, replace part. The next process, test. So decision again. If it is fail, if pass, we prepare the report, call the customer to collect, and customer get the units. This is simple flowchart. Besides having this simple flowchart, maybe we want to show to the auditor that we have procedure or we have SOP. Or maybe if customer asks what is the process for repairing my unit, you can show this to your customer. But sometimes when we have bigger map of processes, this flowchart can help us also for Kaizen, for improvement, where we can find any bureaucracy, any redundancy, any overloading, or waste. You remember, muda, muri, murah. We can see the muda, muri, murah happening as well in our processes. So this is an example. Home occupant process. This is the current one. Start from here. Pardon? Yes.
At this flow chart, and I saw this analyst review.
So, analyst review, yes.
It's not supposed to be a diamond, is it?
This is diamond action, but this is analyst is the review is the process. They are doing something. They do the analysis. So result from the analysis is the action decision here.
Okay.
Okay. Okay. This is start. It should be round square maybe. So start here. Customer submit application. Maybe submit manually or online. Depends. Customer submit application, then decision has to be made. Check the application whether it is complete or not. If not, return back. If yes, we submit to the department specialist for login. Maybe they have system to log in. And then deputy director is assigned. Then they assign analyst to review. Analyst to review. Maybe require site visit or maybe require further research. Or maybe it doesn't require this. Straight away, analyst review, then make decision. If reject, maybe give back to the applicant or applicant withdrawn. If yes, they come up with the action letter. Can you see any bureaucracy here? Waste. Can you see any waste here? Remember last time we learned about 7 waste. Maybe this is a waste.
A sign. Yeah.
Yeah. This is also waste. Think about empowerment. If we can empower making the decision making to our employees, maybe it can speed up the process. Remember, simplicity. Simplicity. To make things simple. Remember lean last week. So why don't we do it like this? Customer submit, we empower the front desk. Under quality management, we have to practice empowerment. Previously, everything will be made by the deputy director. Maybe they are busy. So we empower the front desk. So education is important. Education and training. Like Dr. Deming said, we cannot just instruct our employees to do the task, but we must educate them and on how to do the task. Then we can empower them. If you were at my age, you remember one time when we go to the bank, we have to queue at the counter until outside the bank. One time UTM has a bank and the bank very small. Most of the things we have no online banking that time, so we have to queue at the Bank Bumi Putra. You remember Shalinon? Bank Bumi Putra.
Yeah, bro. Very small bank.
So you queue there, and then there's a cash teller here. Teller will accept your receipt. Even in the UK also worse, I think. Even in 1997, I was there. Teller, I passed the receipt to the teller. Okay, I want to withdraw my money. And then, let's say I want to withdraw £100. So, how do you like the money? The popular question. How do you like the money? What was the answer, Sharinon?
I like it very much.
I like it very much. And the guy give the answer. I like because the money look beautiful, the queen's there, and blah 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 blah. That was the question actually. What they want to know. Okay, £100. You want to withdraw £100. So the change you need, maybe 50, 50, £10, £10, or whatever. But maybe because of the British, they ask different way than American or than in Malaysia. Okay, we'll go back to this one. But in Britain, I still remember when you want to draw £100. Okay, they give you £100. Here they are, your money. Thank you very much. Have a nice day. They take the receipt, but they didn't key in anything. They will key in after finish the business hour. So if you have not enough money, it will be minus in your account. They call it overdraft because everybody are given overdraft facility £200 if I'm not mistaken. So we go back to this example, okay? And during those days, there are officers sitting here. This is a waste. And then the teller will pass the slip to the officer, and then the officer will check the slip and then take whatever. Is it correct, Sharinon? Those days?
Yeah, like that. So
and
we
this
have
is waste. This is waste. Now, I notice in CIMB, the teller is the officer. They have basic degree. They are officers so that they can make the decision. So the process can be simplified. Front desk can make decision. If not complete, the front desk themselves will pass back the application, or if it is complete, pass to the department specialist login. They log in, put into the system. Straight away, the same people, front desk can make decision. Whether it is denied or yes. So using this approach, it is more lean. We have eliminated this bureaucracy. Same like in our organization, when the processes of approval something, it should gone through couple of meetings is a waste. But we go back to the culture as well. In some culture, they have tendency of mismanaged, accountability issues. So that's why we have to build the accountability, amanah. So if everyone amanah, if everyone accountable, honest, so a lot of things can be improved, particularly our system. The country that has a lot of bureaucracy because the country has a problem with corruption, high number of corruption. So that's a concern because when we have a lot of bureaucracy, it will affect our competitiveness of the country. Okay, this is another way to map the process. We can also map the process based on the person in charge. This is the person in charge. We can map based on person in charge. For example, drilling permit. The drilling permit application submitted to Department of Water Resource by owner or representative or driller. Application package may include other documents such as map and schematic. This is done. Responsibility PIC is applicant. Submit to the office. Who will do this? Clerical staff. Check the permit. If it require fee, process fee. If no, review for completeness the form, the application. So if yes, they give the scan data, give full tag. This is the thing. Maybe in the company they use that. Scan permit document, email to professional staff. Scan and then email to the professional staff. Maybe they have appointed professional staff. And then the document they have scanned, they keep in the storage for record purpose. So until they keep documentation, filing also in the process. So what happens if we don't have this? You don't know where to put the document. Then the side effect is a documentation problem. When the auditor comes for audit, you don't have the evidence because you do not have proper filing. So filing also should be in the process map. Then send tag and receipt to the professional staff. And A means connector, continue next page. Continue here, connector here by the professional staff because we have sent the stuff to the professional staff. What professional staff should do? Review the application on computer for regulatory compliance, check on the compliance, then check drill site location and so forth. Then monitor the well program required by the government or by ADC, maybe this is the system. If yes, get the certified professional engineer. No, develop condition for permit approval, prepare draft permit for review, then pass to the manager. Manager, very easy, just make decision only. So if no, reject, give letter of denial. So as you see here, reject also they have procedure, what to do next. Same like when we interview new staff, there should be a procedure for that. People, applicant apply, then we interview, or maybe we didn't shortlisted. So what's next? We have to show that prepare letter of denial to the applicant so that the staff will know what they should do, the prepare letter. Otherwise, they just keep quiet because no procedure to tell them that they have to prepare letter. This one, if yes, approve, print permit, copies for signature, file, but the permit will be sent online, but the hard copy one should be filed. So this is example if we want to draw the process map based on person in charge. It can be drawn by vertical or horizontal. It depends. And we can use this process map for the supply chain as well. So by having this, we know where is our problem, because we can demonstrate this on a piece of paper or in the computer screen. This is for supply chain. Then those who have learned lean operation, this is your familiar already. This is what we call visual stream mapping. Why we use this? Because we want to identify the 3M, mudah, muri, and murah. There are a couple of my students who did the improvement on the value stream mapping at the company as their master project. And basically, we have gone through a couple of quality tool. I begin with the cause and effect diagram, check sheet, control chart, 5S. See, from the beginning in this lecture, I mentioned about 5S. Failure mode effect analysis, that is, then we calculate the risk priority number. We have histogram, we have Pareto chart, we have run chart, scatter diagram, certification, survey, and flow chart, and so on. And these are the purpose. We want to investigate cost. So we can use maybe check sheet, we can use Pareto, and so on. So beside those 7 quality tools, we also have new tool for improvement, such as affinity diagram, interrelationship diagram, metric diagram, process decision program, chart, affinity network diagram. This is, you are familiar with this in the project management. You have critical path method and so on, prioritize metric, and tree diagram. You can browse in the internet how to use this metric diagram and so forth. But here, I want to share with you about the affinity diagram. For the affinity diagram, we can link with the interrelationship diagram, because from the affinity diagram, actually, we can see the relationship of the issues, sub-issues, as well as the idea to solve the sub-issues. So we want to see the relationship. So we can do the relationship as well. And by combining these two, we can have the tree diagram. And under the tree diagram can help us on the decision. So we can extend to the priority metric or the metric diagram. Okay. This is how to create the affinity diagram. Maybe you can use team member, or maybe you can just use Google form to do this. And then everybody from anywhere can put their information. Maybe you have one issue. Maybe your issue is can you tell me one issue?
Cannot withdraw money.
Cannot withdraw money. Yes, easy. That's the issue. So what is the sub-issues? You have to find out the sub-issues. So whatever way, you get ideas from your people. So everybody should give you, okay, today we collect the sub-issues. What are the sub-issues that relates to the cannot withdraw money. Or maybe we can use fishbowl, cannot withdraw money. So what are the issues pertaining to the man, material, method, environment, or whatever? So from there, you have classified the sub-issues. So it can be combined with the cause and effect diagram. Then the idea, this needs time. In some organization, maybe they have a war room, one room, they put one big board there, they draw the issue, sub-issues. So maybe you can brainstorm the sub-issues, or maybe they, okay, you give time, okay, for these 3 days, everyone should share or write the sub-issues that you think that relates to this problem, cannot withdraw money, for example. Write down the sub-issues. Just sub-issues only. Then from that sub-issues, you classify, like you did on the cause and effect diagram. Due to man, due to environment, due to equipment, or whatever. You classify those, then maybe you can come up with one theme for that classification. Maybe you do not use man. Maybe you can use human error, maybe human problem instead of man, human error. Okay, under human error, for example, for sub-issue. Another one maybe equipment down, server or whatever. So what are the ideas that relates to the sub-issues? Okay, after these 3 days, everybody have to give the sub-issues, and then you brainstorm, you classify. After that, you announce, everybody has to come to the war room, write down their idea to solve any of the sub-issues. So in the board, you already put the sub-issues there from your discussion. Then everybody will come to use, write on the stick on notes, paste the sub-issues. So after finish that, you discuss on the idea. So when you discuss the idea, maybe it's like this. Issue with implementing sale reference tool. They have problem to implement sale reference tool. This is the sub-issues. Sub-issues on the evaluation, support, training, and so on. And these are the idea. And the evaluation, important to do it close to right the first time, but be flexible to make change later. Training, for example, what is the best way to train? Training backup for administrative support of guide. Selecting someone to provide training. These are the idea given by the team. So if you leave this like this only, it just tell you idea, but sometimes just abandon like this. Why don't we analyze the relationship? This is the example. From the idea, we see, is there any idea that has relationship to others? For example, this one. This one, avoid perception of taking creativity from other salesperson. Where is the relationship on the plagiarism here? This is about plagiarism. Where is the issues that relate to this plagiarism? So we have to find out from here. We can't be too fancy on the size issues. So where this related to other sub-issues? So you have to find out. So when we have the relationship diagram, we combine the relationship diagram in the affinity. After we complete affinity, we do the interrelationship. Draw a double box around the key factor and brainstorm ways to address these issues. Like this. the sub-issues, under the sub-issues, the idea or the concern by the people is poor need definition and many simultaneous job. Then poor need definition because of what? Because our customer don't know what they want, lack of communication, too many options, too many hand import. There are issues with the missed delivery dates. And then under many simultaneous job, what are the problem with this? Communication also, market forecast, blah, blah, blah. Unfortunately, you see that lack of communication is also related with these two. Lack of communication is related to these two. So here you can see the interrelationship. So count number of arrow pointing to each node. Identify the card with the most issues as key factor. What is the key factor? Maybe they use card, or during this IT era, we can use Google document maybe. Okay, what is the key issues here? Maybe the communication issues. Because just for this one only, poor need definition and many simultaneous job, it shows that maybe lack of communication is the problem. So by using affinity diagram, then you combine with the interrelationship diagram, you can find out what is the actual problem in your organization. And this is another example for the interrelationship diagram. This is the idea from the sub-issues. We will need backup system administrator. What do we do with the effect goes down? And blah, blah, blah. So these are the idea that we get from we obtain from the affinity diagram. Then we link the relationship. So the idea that has, or the problems that has more connection, maybe that is very important. And this is tree diagram where you have major issues here, you have sub-issues, then you have topic. So under each topic, you find out the ideas. So we also have prioritization grid for making a decision. We have metric diagram like this, metric diagram. People needed, we need what? Well, engineer software, blah, blah, blah. And this is the problem option to reduce the billing error. So we have the weightage here, high, medium, low. Then we put the score. So we count the score. It shows that in order to reduce billing error, we need more engineer, because engineer has to do this task. This is process decision program chart. X and O. Upgrade job description, define job requirement, develop new pay scale. Under define job requirement, what are those? And then this one for develop new pay scale. And this is the logics. This is process decision program chart. Activity network, similar to your project management. You want to see the relationship, and then this spider chart also familiar to you, I guess. And balance scorecard can be used also to show your information. This come from your strategic planning, for example, your strategic team objective, your measure, your target, initiative, and then maybe you can put in another column your achievement. So maybe you can use this as a report card as well. So maybe in your organization, all personnel should be given a report card. And based on your balance scorecard, you have to monitor their monthly achievement for their particular objective. Maybe you can adapt this as well. This dashboard is very popular nowadays. That's all on the quality tool.